I think EPIs are actually fairly comfortable with ambiguity because we don't operate in a lab setting. We can't control, there's not an SOP for an outbreak investigation. There are guidelines, but every decision you have to make is going to be weighing multiple factors.
All right, welcome everyone to the Bioinformatics Lab podcast. I'm Kevin Libuit, today with Krisandra Allen, and we are from Pathogen. Today we're going to be talking about the epi perspective to this conversation of bioinformatics and genomic sequencing data and all the challenges that there have been traditionally in the integration, but also highlight some of the solutions and ways forward that labs and epidemiologists can work forward to properly using this really powerful technology. And I think before we hop into, maybe the nitty gritty of things, Krisandra, can you kind of level set us a little bit and speak about what is infectious disease epidemiology, and maybe more so, what was the general practice prior to integrating sequencing data in bioinformatics?
Yeah, thanks for the question, Kevin. Infectious disease. So I'm going to really focus on applied epidemiology. So there's two branches in infectious disease epidemiology. There's the academic side, and then what we call applied, or kind of the shoe leather epidemiology that you might think of. And that's really what's being done on the ground, on the front line at state and local public health, federal public health as well. So in those instances, epidemiologists are really working directly with the public, working directly with facilities. So you're trying to, you might be getting case reports. So there's diseases that are required to be reported to health departments. It might be norovirus, it might be salmonella, whatever it is. So epidemiologists are taking in those reports, and they're really looking for patterns. So they'll call patients, they'll do interviews, they'll find out what exposures they had, be that food if you're looking at salmonella, be that a facility if you're looking at a potentially healthcare related infection. And then you're trying to put the pieces together. And it can be really hard with really small numbers. So if you only have a couple people, if you only have two cases, finding out what two people have in common, unless it's really obvious, like, oh, they both ate at this one particular restaurant, or they both went to this one particular facility, it can be really hard. So that's where being able to know going into investigations whether two people were likely to have gotten their illness from a common source is a really, really helpful piece of information. So you don't spend a lot of time trying to link cases or look for connections when they're not going to be there.
Okay, that's super helpful. I always think about it as like detectives. Again, I think the analogy you brought together of just looking for patterns is just something we can all relate to, of trying to connect the dots and see how the disease is spreading. And so can you speak to then, if you're trying to connect the puzzle pieces, having more puzzle pieces is helpful, or at least informative puzzle pieces in the genetic data? And can you speak to how that adds context to the roles epidemiologists are playing in these infectious disease surveillance programs?
Yeah, so those genetic pieces can really help on the front end build your hypotheses. And then on the back end, as you investigate, they can help confirm what you're seeing in your epi investigation. So just thinking back to some of the investigations that I've worked on, I had one situation where I originally investigated a case of invasive group A strep. And my initial interview didn't find any connections. It just seemed like a community random case. And then a couple of weeks later, I was notified by the state lab that said, hey, this case is actually closely linked to another case at this healthcare facility. And knowing that information, that I was able to go back and interview the patient again and go back further in their timeline and in their history. And I was able to find the linkage to that facility. And that kicked off an outbreak investigation, which included a lot of interventions and changes made at the facility. So getting that genomic data to kickstart the investigation I wouldn't have connected it any other way.
it just gives you another vantage point to look at what's happening here. And you can see, I think, in the way that you described it, the sequencing data is always meant to be complementary to the epidemiological data in that it can help build the hypothesis, as you said, and also help to confirm. And I think that's definitely something that we actively work to dispel in the community of like the bioinformatics data it can't stand alone. It always has to be in conjunction with the epidemiological information in the context of, what we understand about how the disease is spreading. And I think that we're kind of speaking to that would be almost the ideal state where you have this cohesive aspect of genetic data getting into the epidemiologist's hands so they can piece all the or put together all the puzzle pieces they have, and this just adds to the clarity of the picture. And this kind of comes to, I think, the phrase you have here of turning sequencing into surveillance. Can you speak to that a little bit?
Yeah, that's one of my phrases that I like to use a lot when I talk about the state we want to get to. So you can sequence a whole bunch of things, and if they all come from one particular subgroup, then you're not going to be able to make a lot of statements or inferences about how that reflects your population at large. So it really matters how you design your sequencing to match your epidemiologic data so that you're ensuring that what you're sequencing is, as far as possible, representative of the community that you want to be monitoring. So by integrating, the work across the EPIs, across the bioinformaticians, across the frontline molecular biologists, you can build a system that lets you monitor the population as a whole. And then when you have that background data, it's a lot easier. When you know what's normal, it's much easier to spot what is unusual. So if you're only sequencing reactively, or only in really select circumstances, it's really much harder to interpret because you don't know what your population looks like. But when you start to build these integrated genomic surveillance systems, you have that background knowledge of your population. So when you see an outbreak at a facility or a cluster, a genomic cluster that the EPIs want to go investigate, then it just makes it much easier to see if that's really something concerning.
I think that's exactly right, because you need to know the context of what's happening. And see, watching blips, I mean, I think about like epi curves and things like this. The reason that you're doing all that sampling over time is you could see what baseline is. And then if you see a perturbation or some kind of spike, it's like, oh, something's happening. Similarly with, the genetic data, I think we're primarily speaking of phylogenetic relationships here. If traditionally you see a number of cases and they're all disparately related, okay, that's the background. But then once you start seeing a kind of cases start to cluster at a high level and at higher numbers over maybe a specific certain point of time, that could be something that would ping the epidemiologist of like, okay, this is worth investigating. This is where we should be able to apply our otherwise pretty limited resources. I think that's probably a big part of this conversation too. It helps to really hone in on where epidemiologists can spend their time, because getting, just like you said, on only case reports alone, I'm sure there's a million of those that get flooded to death, but identifying what the priority cases are to really investigate and build a investigation upon is difficult to do without this level of granular information in front of us.
Yeah, and I think you also need to build in those informatics systems. So if the lab is sending you a line list and then you have to kind of backtrack and say, okay, how do I match this back to what I have in my epi data? It's not going to be something you can do at scale. You have to build those connections and automate them so that the epidemiologist can really see at a glance, all right, the lab is telling me this is my cluster, or these are potentially an outbreak. And then you can see at a glance, here's all the epi data. Oh, I can see right away, all of these are associated with one particular school or facility or whatever other critical information that you have.
Okay, this is a great part of the conversation to segue into. So to kind of just before we hop into this, what we're speaking about is maybe the ideal state, the obvious, or not the obvious, but like really the pursuit of integrating bioinformatics into the epi investigations or turning sequencing into surveillance, where the epis will be fed this information that's so critical to their positions of not only getting the case reports and things like that, but also the genomic epi reports that give additional context to the puzzle that they're building there. But to get to that, there's obviously a couple challenges and hurdles. One of which you've spoken about already is the integrating into surveillance systems, like their active methodologies for tracking these types of reports. So, can you first speak to what is a surveillance system, pathogen surveillance system, and what are those challenges? Why is this not something that we're seeing just readily adopted, given how this is obviously sort of the ideal state of where we want to walk towards?
Yeah, so thinking about, a surveillance system at large is the whole everything from policy to deciding what is under surveillance, and then it's also the mechanics of the actual systems, the databases that are holding the data. So some of the challenges might even be upstream of, do our disease reporting regulations require submitting of sequences. So if
Mm.
academic facilities start to sequence their own pathogens, do we have the policy and legal reporting requirements to get that sequencing data in the door? Do we have the networks built with the clinical laboratories to be submitting representative samples as much as possible across a range of pathogens? There are a number of pathogens where labs are required to submit everything they identify, but then there's quite a few pathogens that don't require that submission. So unless you specifically set out a surveillance system, then they're not going to be reporting specimens for those. And that requires then looking at your lab coverage and saying, all right, how do we get at least a geographically representative data set? How do we get a data submission set that is maybe representative of both community and hospital cases, etc.? So you have to design kind of the whole surveillance cycle from the beginning of understanding why you want to build the system, how to build the system, and then actually building in the infrastructure to do it. And then the goal of disease surveillance is to drive action. So when you're designing your genomic surveillance system and integrating it in your overall disease surveillance system, you want to be always having that goal in mind of how are we going to use this data in public health practice? How is this going to change how we do our investigations, how we make recommendations, all of those pieces. So there's a lot of pieces along the way of designing a surveillance system, and of course you have to have the funding and the infrastructure in place to be able to move these samples physically around, move the data around.
I think that's such an important point in where you're speaking about. It needs to be coordinated at the policy level, at the lab level, and then also at the epi side of things, which are also traditionally worth saying, especially for international folks who might be listening to this. In the US, sometimes those are separate entities. The laboratory institution versus the epidemiologist or Department of Health that is actually conducting the investigation itself. So it could be sometimes cross organization coordination required to put in play a proper program. And so policy, that's one conversation maybe out of scope for this discussion. But the communication aspect of getting it integrated into a surveillance system, can you speak to that in terms of if there are laboratories asking or looking to send the data to epidemiologists, what data needs to be sent? What is the useful information that becomes actionable to drive the decisions on the epi side?
Yeah, I think that's one piece where it gets much more tricky on the implementation side, because we're not going to be sending the actual sequence data over to the epidemiologic databases. They're not designed for that, not a good use. Um, so it will depend pathogen to pathogen. So for a salmonella, maybe it's important to send the serotype. For Klebsiella, maybe you want AMR gene detections. So it needs to be in concert between the bioinformatics and the epi of, for this pathogen, what is important. I think one key thing I always like to see sent is if you're putting that sequence into a public repository like NCBI, it's really, really helpful to include that accession number in the data that gets transmitted to the epi data system, because if you have that connection, we saw this with COVID some, where initially we would put in the pango lineage would get pulled into the epi surveillance system, and then, oh shoot, we run it a couple of months down the line and it gets assigned a different lineage. So sometimes the outputs of your genomic analysis will change. So that's why it's really critical to keep that identifiable link back to the original data so you can always update, and if you're doing an analysis, you can pull all those sequences and rerun them using the same version of the tools for your analysis.
There is so much nuance to the outputs you were speaking about there, especially on the bioinformatics side. I'm wondering if you can speak about um, the opportunity for bi-directional learning, right? I think a lot of the things that you spoke about is the language of bioinformatics scientists when looking at lineages, looking at AMR reports and things like this, and even some of the phylogenetic interpretation aspect of this too. What do you feel EPIs can start learning or integrating into their just vocabulary and understanding of sequencing data to really make this impactful? And then after this, I'm curious to also hear your thoughts on what bioinformatics scientists can learn from epidemiologists to properly, direct their reports to action.
Yeah, that's a big question. um, I think EPIs, the one of the key things I want all EPIs to learn, I think, is just the complexity, and it's not the outputs of the bioinformatics pipelines are not just biological realities that we're discovering. They're things that we're inferring using tools, and I think understanding that sometimes the outputs will change, they will look different, um, and just having care in interpreting. And I always love working directly with a bioinformatician because I have so much respect for the complexity that goes into it. So learning some of the basics, the tools, the interpretations of outputs, asking a lot of questions. If you get a report that says MLST type, which I guess is redundant. Um, but asking the question of, oh, hey, what does this mean? How is it generated? How can I use it to help my investigation? Um, because there is so much vocabulary and that I'm still learning, that everybody is still learning because it changes constantly. That's the other thing that I've really taken to heart, is that if you're not moving forward, you're going backwards, because the field doesn't stand still. What is the important output this year might be different than the important output in 3 years for the same pathogen. So I think that just underscores the importance of the relationship and that continual learning together.
That's so important too, of just being able to have someone to speak to and have that bridge of communication built from the lab side to the epi side. Because yeah, this isn't a pulse field gel electrophoresis banding type where there's really only so many variables I can speak to. Either it matches the type or it doesn't. Whereas the bioinformatics output, I mean, it's based off of millions of data points that are being interpreted in really specific ways, and there are parameters you can change along the way. So that like level of granularity comes with some level of ambiguity that you almost have to be comfortable with and have an active dialogue with your bioinformatics scientists to understand how then you inform action. But of course, this brings in the level of discomfort, because it's like, how do you distill all of that into red light, green light? This is related. Don't act, act. Can you speak to that a little bit?
Yeah, I think that is one part where it gets there isn't desire for that level of clarity. But I think the other key part to remember is that, like you said, way back at the beginning, the genomic data is never the only data point being used. So I think EPIs are actually fairly comfortable with ambiguity because we don't operate in a lab setting. We can't control. There's not an SOP for an outbreak investigation. There are guidelines, but every decision you have to make is going to be weighing multiple factors. You might have environmental health inspectors giving you information about, this is what we saw going on in a kitchen. And you might have your interviews with the patients, you might have an interview with a restaurant manager, and then you have your lab giving you, here's the genomic data. So EPIs are always used to this balancing act of, does A plus B plus C equal green light or red light. So I think EPIs can handle the ambiguity. I think it's just communicating that it's there, especially for those of us that have been around through the transition from the older methods like PFDE, where it was much more of a kind of binary, this is your cluster, they all have the same pattern, to now the spectrum of relatedness.
Yeah, there's now a lot more footnotes in those reports because yeah, I think especially for the folks on the bioinformatics side, when you're doing phylogenetics, something like relatedness, there's a million factors to consider. So making sure you have vetted processes, and at the point of the field right now, you definitely need that subject matter expertise to look at things. But that's why I think what you said is so important of having that communication portal open for the EPIs and the bioinformatics scientists to speak on, okay, what am I looking at? What are the caveats I should consider? What is the confidence level of looking at this relatedness? And then that could be another piece of just epi data for them to look at and being able to translate that and weigh that against all the other factors they're looking at. And what we're seeing also kind of emerge on the epi side, and maybe sometimes on the lab side, is this sort of intermediary role of a genomic epidemiologist. Can you speak to this? And in some respects, I think, is it fair to consider yourself as a genomic epidemiologist?
Yes, I would happily take that title. Um, I think yes, the I don't want to generalize, but not all bioinformaticians can speak their field in a way that the epidemiologist can understand, and not all epidemiologists can understand the what they're hearing from their bioinformatics scientists. Some people on both sides are really great at doing that crossover and translation, but this is where we've seen in public health, it's been really exciting to see the growth in these genomic or molecular epi roles that are really designed to kind of stand in that gap of, because traditionally in at least US public health departments, at the state level especially, people are pretty program area siloed. So you'll have an epidemiologist that works on foodborne diseases, one that works on vaccine preventable. And so they don't always have the time to learn deep methodology about genomic data. So, and the bioinformaticians don't have time. They may be covering 10 pathogens. They don't have time to spend deeply with every single program area. So this is the role that the genomic epi can come in and fill. They can work really closely with their bioinformaticians to grow their understanding both of the processes, the outputs, the data, and then they can help translate that to those field and frontline epis, health officers, um, medical facilities, etc. Because if we don't get the data translated and understood well enough by those frontline people who are interfacing with facilities and things like that, they're not going to use the data if they don't understand it. So I think that's the really fun role that those in the genomic epi world get to sit in.
Do you find people in that role generally come from the epi side or the bioinformatics side and then find themselves in the middle?
Uh, I have been more involved with the people that have been coming at it from the epi side, probably just because that's my background. But there definitely have been people on the bioinformatics side that really have kind of built the bridge from that side as well. But I do think, there's a lot of epi concepts that we tend to see. Most of the trainings you'll see are teaching EPI's bioinformatics. And most of the joint trainings even are, teaching EPIs how to understand bioinformatics outputs. And it's pretty rare that there's specific trainings or focuses on, let's teach the bioinformatics scientists what EPIs do. And I think that's a thing that can really help bridge and help the bioinformaticians reach forward towards the EPIs, even just basic EPI concepts like design of surveillance systems, like case definitions. So now case definitions, it's a really critical part of what EPIs do every day for both surveillance and outbreak. And now we're starting to see case definitions that might include genomic data, like the Pseudomonas and artificial tears outbreak, if you look back at that one, the case definition for the outbreak included the sequence type as well as a couple AMR genes. So if bioinformaticians understand what a case definition is, how it is used, then they can help when there's genomic components that can be put into that case definition so we can get to better case definitions. And then just learning things like standard epi study methods like case control studies, cohort studies, and measures of association like odds ratio and risk ratio, and kind of all those generalized epi things can be applied really directly to combined genomic and epi data. So I think it would be really fun for bioinformaticians to be able to be exposed to that side of the world too.
I'm so glad you brought that up because, yeah, that kind of gets back to the original question. And I think on the EPIs learning bioinformatics side, one crucial thing that you mentioned is for EPIs to understand the nuance of this and just getting used to the language of, bioinformatics there. And that in and of itself can go a long way. And then what you just mentioned here on the bioinformatics side, for them to be more effective in translating this into action, it's understanding these basic, really foundational concepts of epidemiology, which I would tell you, someone who was in the bioinformatics role, especially at the state level, I never got an understanding of what is a case study, what are these stats and odds ratios that you're speaking of, and study methodologies. That was way outside of what I was ever concerned with. But I think now, over the past couple of years, I'm starting to really gain appreciation for how much on the bioinformatics side can be learned from the epidemiologists to make sure, yeah, there is that proper bridge built in communication, and the software we're building, the outputs, the reports that are being built on the bioinformatics side can land into the epidemiologist's hand in a language that they understand.
Yeah, I got nothing more to say. That was a great summary.
All right, perfect. So then I think we'll, over the past couple of minutes or 20 minutes or so, we've been talking about, the ideal state of merging these fields, and we're seeing it actively happening where, again, you mentioned the artificial tears outbreak. There's been a number of foodborne outbreaks across the U.S. and other HAI kind of case studies where we're seeing institutions properly turn sequencing into surveillance. And we've also highlighted a number of the different challenges, one from understanding the language each other speak, the policy discussions, the informatics conversations, and the complexities around that. Can you speak to other solutions that you've seen in the field of like, okay, if you're a lab and you're an epi, hey, here's some low-hanging fruit that can really be addressed to start this wheel churning and properly turning sequencing into surveillance?
Yeah, I think the one key thing is just finding the right people. So
Ooh.
if you're on the lab side, bioinformatics side, and you have all this great data and you don't know how to get it across to the people that you need to get it to, looking for the right person. That might be even going to the state epidemiologist or kind of the higher level decision maker if it needs to go up and then cascade down. But also building the positions. So it becomes much easier if the bioinformatics side has a counterpart as a genomic epi. It's always hard when you're wearing multiple hats. So if all of the epis are assigned to their own specific disease area, then nobody has the bandwidth to be that bridge to the lab. So we are seeing more roles that are both in the genomic epi, but then roles like lab epi connector is position that I've seen before. So just trying to identify the key people is a really, really important first step. And then once you've identified those people, just getting together regularly, meeting in person if possible, watching bioinformatics genomic epi webinars together and discussing them. Including your lab or epi counterparts in trainings. One of the most impactful things on my journey was the AMD training supervisor invited me to come to a week-long bioinformatics course. It was targeted at lab people, but it was my first time we used Galaxy and a little bit of the command line. And for me as an epi to go spend a week learning that, that was the first time that I had built a pipeline, and it made it so much easier to understand. So trying not to silo people into, oh, they're a lab person, they can't take this epi training, or they're an epi person, they can't take this lab training. Give people the room to grow and stretch and learn. So I think, yeah, coming back to all of that, the relationships are really, really the first step. And then from there, often it's, the informatics part is less of a barrier once you get the personal and the relationship and the buy-in from your agency is really critical too. Then you can start making steps of, when I started first doing this at the state level, it was a fairly manual process of getting spreadsheets from the lab and then manually importing that data into our epi disease surveillance system. And that is a great place to start. Or maybe you start with, I can export data out of my epi system, I can export from my lab system, and this is how I can marry them up and analyze the data. And then maybe once you can show the value, then you can get buy-in and support for building those automated connections. So it's step-by-step process.
That's such a great answer, right? Because I wasn't sure you were going to take it. I didn't know if you were going to talk about maybe the integration of informatics or the details of the training. But no, I think even first and foremost, establish the connection, ensure that there are aligned incentives. Hey, we're all on the same team here. If we can start there, all the technical challenges become very surmountable. They become something that we have verve to overcome. And then you can even just start drawing on the examples across the US, across international space of people who have solved those similar problems. So, and really, I think what you and I are both hoping is that this can serve as a resource for epidemiologists or laboratorians of like, hey, send this podcast out to your epi, so so that you can speak to what the benefits are in terms of working together and meeting on the same page. So, I think that is a very good first step. Identify the people who have that same energy to push the field forward in this way and adopt what is really such a powerful technology. Like the way I was always talking about it with the labs, and it was also always a challenge in integrating the technologies even at the labs. But you talked about the academic and applied aspect of epidemiology, and I think what we've seen in the academic space is that there is no doubt at this point that this is the most effective technology to bring this resolution to the space. So there's really the obligation of the community to adopt these things and find a way to bridge the gap, because on the lab side they want to be useful. They want to be doing things that are actually actionable. And then on the epi side, they want to take action with the best resolution and confidence in their decision making as possible. And this is what this kind of connection can offer.
Yeah, exactly. And I just want to go back one thing on the building the relationship to your comment of the lab wants to be useful. I think one thing that's really, really important in these relationships is that there's the view of each other as equal scientific partners, and that the lab is never a service provider. The lab folks are equal scientific partners in this work, in these investigations, and being able to have that productive relationship. It's really important to see the other perspective and include people fully as much as you can in the outbreak investigations, in the outcome. Don't take the data, find some cool findings, and never report back. Just keep that open communication and work together as completely as possible.
Yeah, 100%. I think just keeping the perspective of collaboration is key. Just again, to your point, this is a whole genomic surveillance system of which these are all pieces to it. So I think this is something we can talk ad nauseum about, and I'm sure we will in future episodes. But I think this was a great just first swing at providing the perspective on the epidemiologist side of things to this conversation of bioinformatics integration. So is there anything else you want to end on for folks about this topic?
No, I think we hit everything, at
All
least for
right,
the first
solid.
round.
Yes, at least for the first round. I'm sure there's a million threads we can continue pulling on everything that was brought up today. But that's it for now. So we'll see everyone in the next one.